Alright, here we go with Class 9, Quadratic Equation Word Problems. What we're going to do is look at, you have a vertical motion model. This is your vertical motion model right here. H equals negative 16t squared plus v times t plus s. Now, what each variable represents. H is our height, t is our time, v is our initial velocity. Oops, two L's there. Initial velocity. And s is our initial height. Okay, and I didn't finish. Alright, so hopefully you can read all that. Now, when you're doing these, you're going to fill in v and s with what's given to you. Okay, negative 16 is our constant in terms of gravity. That's just if you drop something, it falls to the ground, gravity pulls it. That's our negative 16. Okay, so looking at number 1, a rock is dropped from a riverbank that is 4 feet above the surface of the water. So right there, that is your initial height. That is going to be our S. After how many seconds does the rock hit the surface of the water? Now, it says a rock is dropped. That means there is no initial velocity, or our initial velocity equals 0. Okay, when it is just dropped, you have no initial velocity. Initial height is 4 feet above the surface of water. So after how many seconds, so we're going to solve for t, does the rock hit the surface of the water? The surface of the water, that's when our height equals 0. Alright, so we're going to solve. If you take your formula, negative 16t squared plus v times t plus s, fill in what we know. We know we want to solve for when the height is 0. We know that our initial velocity is 0 and our initial height is 4. So that can be rewritten, 0 equals negative 16t squared plus 4. To solve that, I can take out negative 4 from each. Okay, this is just from here solving a quadratic. So when we factor negative 16t squared plus 4, I am going to take out, now you can take out a negative 4 or a positive 4, it doesn't matter. Because t squared is negative, I'm going to take out a negative 4. I like t squared to be positive, it just makes it easier. So when we take that out, negative 16 divided by negative 4 leaves us 4 t squared, and 4 divided by negative 4 is negative 1. So now when we solve this, we have it equal to 0. We factored out our greatest common factor, and now we continue to factor 4t squared minus 1. Well, thinking back to all of our different factorings, we know that 4t squared minus 1 is the difference of two squares. Alright, so we have 0 equals negative 4 times, what can we multiply by itself to get 4t squared? That is 2t. And what can we multiply by itself to get negative, or to get a positive 1? And that is 1. And 1 is plus, 1 is minus. So from there you set each one equal to 0. Now, negative 4 is a constant, so if you set negative 4 equal to 0, that's not true. That really has no effect on whether or not the rest could be equal to 0, okay, because negative 4 is just a constant. So we're going to look when 2t minus 1 equals 0, and when 2t plus 1 equals 0. On the left side, you get 2t equals 1. Yes, this is my schoolwork. And on the right side, or I'm sorry, continuing on the left, you get t equals 1/2. And on the right, subtract the 1, so 2t equals negative 1, divide by 2, you get 2 equals negative 1/2. So, t equals negative 1/2, that is not, we don't count time in negatives, okay, so we're not going to count the negative time. We have a half a second. So after how many seconds does the rock hit the surface of the water? After half a second. Okay, and that's it. That allows you to solve the problem. Okay, so let's look at the second one. A football is thrown in the air at an initial height of 5 feet. Right there it tells you initial height, so that is our S, with an initial velocity of 16 feet per second. So that is our value for V, our initial velocity. Okay. After how many seconds does it hit the ground? We know when it hits the ground, h equals 0. So if we look at our formula, h equals negative 16t squared plus v times t plus s. We know we want to solve for when h equals 0, and our initial velocity is 16, so that's plus 16t. Our initial height is 5, so plus 5. That's what we're going to solve. Okay, that looks kind of like a tough one to solve. What I'm going to do first, because there are no greatest common factors, I'm going to move everything to the left side. So I'm going to move everything over there. I'm going to add the 16t squared. I'm going to subtract the 16t and subtract the 5. So now it's equal to 0. So now we factor. No greatest common factor. We do have a coefficient in front, so I'm going to multiply. 16 times negative 5. That is negative 80. Now, what can I multiply to get negative 80 that adds to give negative 16? Well, let's try 4 times 20. So maybe negative 4 times 20 or negative 20 times 4. Which one adds to give us negative 16? That would be negative 20 times 4. So, negative 20t plus 4t minus 5, because you bring down that, and you have 16t squared. From there we group it. On the front grouping, you can take out, let's see, 4 goes into both 16 and 20, you can take out a 4t. 16 divided by 4 is 4. 20 divided by 4 is 5. And on the right side, 4t and negative 5, no greatest common factor there, so it's just a plus 1. You're left with 4t minus 5. Now they both have a greatest common factor of 4t minus 5. So you can take that out in front, and you are left with 4t plus 1. Okay, from there, set each one equal to 0. So you have 4t minus 5 equals 0. Add the 5 over. You get t equals 5/4. Okay, and then move the board down. Whoops, a little bit too much. Alright, so t equals 5/4, and then 4t plus 1 equals 0, minus the 1, you get t equals negative 1/4. Now, a negative 1/4, that's a negative time. We don't count that one. We just have t equals 5/4. So, after 5/4 seconds, the football is going to hit the ground. So there you go with example number 2. Alright, we have one more example. Number 3. The student council wants to purchase a table for the school lobby. The table comes in a variety of dimensions, but for every table, the length is 1 meter greater than twice the width. So right there, this is not a vertical motion, okay? So we don't need that formula. But you have the length is 1 meter greater than twice the width. So let's call x our width. So our length, oops, spelled that wrong, length, 1 meter greater than twice the width would be 2x, 2 times the width, plus 1. The student council has budgeted for a tabletop with an area of exactly 3 square meters. So, for a rectangle, we know our area formula is length times width. So, our area, we have an area of exactly 3 equals our length, which is 2x plus 1, times our width, which is x. Okay, so we can distribute. That gives you 2x squared plus 1x equals 3. Now we're going to solve this quadratic. Well, when solving quadratics, you know it first needs to be equal to 0. So minus the 3 from both sides. We have 0 equals 2x squared plus 1x minus 3. Now, when you move this down. Okay, so when we solve this right here, coefficient of 2, can I factor that out? No, 2 cannot come out of 1 or negative 3. So you're going to multiply. 2 times negative 3 is negative 6. What can we multiply to get negative 6? That adds to give us 1. Is it going to be 3 times negative 2 or negative 3 times positive 2? And that would be 3 and negative 2 adds to give us a positive 1. So we're going to split this to plus 3x minus 2x. Bring down your 2x squared and your negative 3. From there we group it. Okay, in the front grouping you can take out an x. You're left with 2x plus 3. In the second grouping you can take out a negative 1. Negative 2 divided by negative 1 is 2x, and negative 3 divided by negative 1 is plus 3. So from there you can take out a 2x plus 3, and you are left with x minus 1. Set them both equal to 0. I'm going to take that over here. So we have 2x plus 3 equals 0, and x minus 1 equals 0. Okay. Add the 1, you get x equals 1. Over here, minus the 3, and then divide by 2. So you get x equals negative 3 halves. We know we don't have a length of negative 3 halves, so cancel that one out. We have x equals 1. So the problem says find the width and length of the table they can purchase. So x equals 1, that would be our width, so we'll width of 1 meter, and a length, 2 times 1 plus 1, 2 plus 1 is 3 meters. So we have a width of 1 meter and a length of 3 meters. And that's how you do word problems. Okay, with the quadratics you have to set up your problem first. With these, it really just takes practice. Okay, here's a practice one to try right now. This is your vertical motion, so you're going to use the h equals negative 16t squared plus vt plus s. Okay, and then tomorrow in class we'll try a variety of more word problems.